Hello children, welcome to the physics class on electrostatics. Now in this we will be dealing with electric field due to an electric dipole at points on the axial line and then on the equatorial line, and then finally the torque experienced by an electric dipole in the uniform electric field. All these three questions are very important. Yes, we'll start with the first derivation, electric field of a dipole along the axial line. Let us consider a dipole AB which has minus q and plus q charges which are separated by a distance of a, and p vector represents the electric dipole moment vector. Okay, now the distance between AO and OB is equal to A, O being the midpoint of the dipole. Now let us consider a point C which is at a distance of r from the midpoint O. Now in order to find out the electric field of the dipole along the axial line, we will have to calculate the electric field at C due to the positive charge and due to the negative charge separately, and then we will have to use the principle of superposition and add these two electric fields and find out the total electric field due to the dipole. So the first step is to find out the electric field at C due to the positive charge. Now you know your electric field equation. So E vector is equal to K into Q by R minus A the whole squared P vector, where P vector is the electric dipole moment vector and this acts along BC. Now I hope you know how you got the step R minus A the whole squared. Now you know the distance is to be found out is BC, but we know that OC is equal to R and OB is equal to A. Therefore, BC will be equal to R minus A the whole squared. Similarly, the electric field at C due to the negative charge is given as E vector is equal to minus K Q by R plus A the whole squared into P cap. Now, this is lying along CA, and if you see the magnitudes of E plus and E minus, E plus is very much closer to the positive charge, so it will have a larger magnitude, therefore the line drawn is larger, whereas the negative charge is very far away from the point charge, that is from the point of consideration C. That is why the magnitude of E minus is drawn little smaller when compared to your E plus. Okay. Now substitute the values of E plus and E minus. You get your E total as that is substituting and taking the common terms outside. You get KU common term outside into 1 by R minus A the whole squared minus 1 by R plus A the whole squared P vector. The next step is E total, that is what they are doing is in the previous step they are expanding R minus A and R plus A as R squared plus 2RA and A squared. Similar, that is they are using the identity A plus B the whole squared and A minus B the whole squared, and then they are cancelling the terms, and finally they arrive the value as E total vector is equal to KQ 4RA by R squared minus A squared the whole squared P vector. Now the condition is if R is very much greater than A, then A can be neglected. Therefore you get it as R squared the whole squared, that is nothing but R to the power of 4. Therefore E total is equal to K into 4AQ by R cube P vector. Okay. Now 4AQ, that is in that 4AQ we know the value of the dipole moment, that is 2AQ. 2AQ can be substituted as P. So it is left only with 2. Therefore E total is equal to 1 by 4 pi epsilon naught 2 P vector by R cube. This is the electric field at a point on the axial line. Okay. The next one is electric field due to an electric dipole at a point on the equatorial line. First we'll analyze the diagram. So here they're taking the dipole AB, which has minus q and plus q charges separated by a distance of 2a. The midpoint is O, and the point of consideration is lying along the equatorial plane at a distance of r from the midpoint O. Okay. And the angle subtended between OBC and OAC is equal to theta. Okay. Now in the same steps you have to find out the electric field at C due to the positive charge and due to the negative charge, and then we will have to find out the total electric field. There is a slight difference between the first derivation and the second derivation. Here if you see, the magnitudes of E plus and E minus will be the same. So what they are doing is they're resolving the E plus component and the E minus vector, electric field vectors, into two components, that is the horizontal and the vertical components. That is the diagram which is shown over here. So E plus, which when it is resolved into two components, it is E plus sine theta and E plus cos theta. Similarly, E minus vector will be E minus cos sine theta and E minus cos theta. Now if you see from the diagram, E plus sine theta and E minus sine theta cancel each other because they are equal and opposite in direction, so they cancel each other. So the resultant electric field due to the point C with respect to the dipole will be equal to E plus cos theta in plus E minus cos theta. Now since the magnitudes of E plus and E minus are going to be the same, then it will be written as 2E cos theta. Okay, I will see the derivation. As I told you, E plus is equal to K into Q by R squared plus A squared. R squared plus A squared, how do you get it? Now if you take the triangle OCB, in the triangle OCB, OB is equal to A and OC is equal to R. Therefore, BC according to Pythagoras theorem will be equal to root of R squared plus A squared. Now since in the equation for electric field it is R squared, you get it as K into Q by R squared plus A squared, which is lying along BC. Similarly, E minus will be K into Q by R squared plus A squared lying along CE. Since both are equal, as I told you, we'll have to take the components, and E total will be equal to E plus cos theta minus E minus cos theta. Now if you add, you get it as E total is equal to minus 2 into E plus cos theta, since the magnitude of E plus and E minus are the same. The negative sign indicates that the electric dipole moment is acting in the opposite direction, the resultant. Therefore, E total will be equal to minus K 2Q cos theta by R squared plus A squared. Now, you know K is equal to 1 by 4 pi epsilon naught, right? Now, from the diagram, you can find out the value of cos theta. Now, you take the triangle OBC. In the triangle OBC, angle OBC is equal to theta. Therefore, from that, if you take the value of cos theta, it is going to be equal to adjacent by hypotenuse. Adjacent is A by hypotenuse is root of R squared plus A squared. Substitute that in this equation, you get it as 2QA by R squared plus A squared to the power of 3 by 2. How do you get that 3 by 2? Because E total is R squared plus A squared to the power of 1. Whereas in cos theta, it is R squared plus A squared to the power of half. 1 and half is 1 and a half. 1 and a half is nothing but 3 by 2. Okay. Now 2QA is equal to P. Therefore, they substituted as P vector 1 by 4 pi epsilon naught P vector by R cube. The condition is when R is very much greater than A. Then A can be neglected. So R squared to the power of 3 by 2 is 2 gets cancelled. You get it as R cube. Okay. Therefore, you get your E total as minus 1 by 4 pi epsilon naught P vector by R cube. Okay. Now, if you note, the electric field due to dipole along the axial line, the value you got was 1 by 4 pi epsilon naught 2p by r cube. Whereas in this, it is p by r cube. That point has to be noted. Next, the points to be noted. Now, for very large distances, the condition is for very large distances, the magnitude of the electric field on the dipole axis is twice the magnitude of that due to the equatorial line, as I told you. Next, the direction of the electric field at points on the dipole axis is directed along the direction of the dipole moment if in the case of an axial field, whereas in the case of an equatorial field, it acts in the opposite direction. That is how you get your minus sign. Okay. Next, the electric field due to a dipole goes to 0 faster than that due to a point charge. Next, you have the definition of a point dipole. What is the meaning of a point dipole? Suppose the distance 2a approaches 0 and q approaches infinity, such that the product of 2aq is equal to p is finite, then you call such a dipole as a point dipole. The next one is about torque, the torque experienced by an electric dipole in the uniform electric field. Now we'll see the diagram. You have a uniform electric field and you have a dipole placed at it, minus q and plus q, separated by a distance of 2a. The midpoint is going to be O, and the angle subtended between the electric field and the dipole is going to be theta. Now two forces act at the positive charge and the negative charge. The two forces are QE and minus QE. Now the force due to the charge Q is given as QE, and the force due to the charge minus Q is given as minus QE. They are both in the direction opposite to the field. That is, the force due to A, that is minus Q, is opposite to that of the electric field, whereas the force due to B is lying along the direction of the electric field. Now, since the external field is uniform, the total force acting on the dipole will be 0. Now, these two forces act at different points, so they will constitute a couple, and the dipole will experience a torque. Okay. Now, this torque is used to rotate the dipole. Okay. And the total torque on the dipole about the point is given as tau is equal to OA vector cross minus Q E vector plus OB vector cross Q E vector. Okay. Now, this is a cross product, and this you have to refer to your right hand corkscrew rule, which we did in your 11th standard. I hope you remember what is your right hand corkscrew rule. If the curvature of the fingers of the right hand represents the sense of rotation of the object, then the thumb held perpendicular to the curvature of the fingers represent the direction of the resultant. That is, it is represented as your cross product. Okay, therefore tau is equal to OA into QE sin theta plus OA into QE sin theta. The cross product is written as sin theta. Okay, therefore you get your value as 2QA E sin theta. Now, what do you infer from 2QA? Yes, 2QA is equal to P vector P. Therefore, you get your value as tau is equal to PE sin theta. Okay, so the magnitude of this torque tau will be equal to PE sin theta. Now, what will be, when it will be maximum and when it will be minimum? Now, it depends on the value of theta. Okay, so this can be represented as tau vector is equal to P vector cross E vector. Now, the torque is maximum when theta is equal to 90 degrees. Naturally, it will be 0 when theta is equal to 0 degrees. So, this point you have to note. And another important point is, if the electric field is not uniform, then there will be a net force acting on the dipole in addition to the torque. Note the point. In addition to the torque, you will have a net force acting when the electric field is not uniform. The next one is your microwave oven. I hope all of you all would have seen a microwave oven, and of course you would have cooked pizzas and burgers in your microwave oven, or else you could have heated something in your microwave ovens. Now, how is this microwave oven working, or what is the principle behind this microwave oven? Yes, this works on the principle of torque acting on an electric dipole. Now, when we studied about the definition of a dipole, we saw the example as, one of the example was water. Yes, water molecules are permanent electric dipoles. Now, the microwaves which are emanating from the microwave oven are oscillating electromagnetic fields, and they produce a torque. Now, the water molecules rotate very fast and they produce thermal energy. Now, this thermal energy is used to heat, that is, it is nothing but your heat. Okay, it is generated and it is used to cook the food. This is the principle of your microwave oven. I end this session with a quote from APJ Abdul Kalam. End is not the end. In fact, END means effort never dies. Thank you, children.